Welcome everyone to a new charter of the Innovation Committee. New day, new challenge, a new opportunity to learn something different. I'm very happy because we have a special guest today, the dear Sridhar Nerur, who will talk to us in more detail about artificial intelligence, opportunity, and challenge. Amazing topic. But first, I want to thank Oscar, Oscar for QLU University and Texas Arlington College of Business for making this collaboration possible. Now, I give the floor to Oscar, who will introduce our guest. Thank you, Oscar and Shidra. Go ahead.
Thank you, Giovanni, and congratulations for all the work that you do in the Innovation Committee in
Thank you.
AmCham. As you said, for me also, it's an honor to present our friend Sridhar Nerur, Dr. Sridhar Nerur, who is the Goolsby, Alcon, Endowed Chair and Professor of Information Systems at the University of Texas at Arlington. He is the chair of the Graduate Studies Committee on Business Analytics at UTA. His research has been published in premier outlets such as the MIS Quarterly, a Strategic Management Journal, the Journal of Management Information Systems, Communications of the ACM, the European Journal Information System, Journal of Strategic Information Systems, the Journal of Association of Information Systems, the Information and Management and the EE Software, and the Journal of International Business Studies. Lots of publications, so he's not just a consumer of artificial intelligence, he's a knowledge producer of artificial intelligence. He currently serves in the editorial boards of Information System Research and the Journal of Strategic Information Systems. He has previously served on the editorial boards of the European Journal of Information Systems and the Journal Association of Information Systems. His research and teaching interests include social networks, machine learning, artificial intelligence, deep learning, text analytics, and graph neural networks. He's a good friend of us, and we are also very glad that UTA, University of Texas at Arlington, will come to Panama to offer, in cooperation with Quality Leadership University, a Master of Science in Data in Business Analytics, starting in August this year. So thank you, Dr. Nerur, and the floor is yours. And welcome to Panama.
Thank you for those lovely words, Oscar. Good morning, everybody. My name is Sridhar Nerur. I'm from the southern part of India. I've lived in the United States for about 34 years now. So I'll tell you a little bit about myself as I go along. But the agenda for today, so this is my plan for the day to talk about the history of artificial intelligence, the types of learning in AI, opportunities provided by AI, challenges and ethical considerations, and AI maturity levels. Before I start, would you go to the next slide, please? I think in my presentations, I had a slide that's probably not in here. I'll get to that slide later on. It's a slide about the collaboration that we are very excited about. Oscar's been to our campus. We've had several discussions, and we are now getting ready to start our Master's in Business Analytics program in Panama. It's a very exciting time for all of us. We are absolutely thrilled to take our program there. So let me just take a moment to introduce the program. I'll tell you my role. We launched our Master's in Business Analytics about 10 years ago. So this is the 11th year of our program. We have done extraordinarily well. Our program is very technical. We take a hands-on approach to artificial intelligence. More importantly, we focus on business problem solving. Unlike a lot of other programs that delve into the mathematics and the theory of artificial intelligence and machine learning and overwhelm the students with a lot of mathematical background, we try to keep it very simple. We offer solutions to industry, period. Our goal is to make our students very productive artificial intelligence and machine learning engineers. engineers so that they can go to a company, take a problem and solve it, right? That has been the goal right from the very beginning. And I think our students have done wonderfully well. Many of our students that are placed at very, very big artificial intelligence companies. Some of them work for Amazon. We have people at JP Morgan Chase, and practically, all the technical companies that you see in the Dallas-Fort Worth area or in other parts of the country, our students are there. Personally, I have been in charge of this program ever since we started it. I teach some of the technical classes. I teach machine learning. I teach a course on advanced artificial intelligence, which involves deep learning. And lately, I've also been teaching ChatGPT. How do you build applications using ChatGPT? In addition to that, I also teach a course on social networks and graph neural networks. More importantly, I teach in the executive MBA programs, both in the United States as well as in Taiwan, where we have a very big program. And the course that I teach is called Artificial Intelligence for Managers. I think it's a fantastic class. We start, people in that program normally do not have a technical background. But believe it or not, within a couple of days, most of them are able to program without writing a single line of code. So I use some no-code tools. We take business problems and we solve them in the classroom. And I encourage my students to get projects from their workplace. One last thing before I move on to my presentation. We also have a certification program at Ericsson, one of the largest telecom companies here in the Dallas-Fort Worth area. We've been doing this for the past 7 years, and I go to Ericsson on premise. I go and teach a couple of classes, and that program has been immensely successful. Ericsson has been very, very happy with our delivery. Ericsson has benefited a lot from our program, and I'm happy to say that we have learned a lot just by engaging with them. Okay, so later on, when I talk about what an organization needs to get into AI, I'll talk a little bit more about my experience with Ericsson. Okay, so getting back to my presentation here, next slide, Oscar, Federico. Yeah, so artificial intelligence is not new. It's been around for a very long time. In fact, one of the earliest papers that was published on neural networks, which tried to mimic the performance of the human brain, that happened in 1943, right? And the term artificial intelligence was coined in the mid-50s, 1950s. 1956, there was a conference at Dartmouth, and a person called McCarthy came up with this term called artificial intelligence. Okay, I will define artificial intelligence in just a moment. The goal at that time was to make machines do things that human beings are generally good at. And what are human beings considered to be good at? Problem solving, theorem proving, playing chess, playing checkers, communicating in natural language. These were some of the things that humans were very, very good at, right? Are still very good at. And a vision, being able to navigate the world, walk around obstacles. So a 1-year-old child can very easily navigate the world, right? Can we make machines do the same thing? That was the goal back then. And the goal hasn't really changed, except that now we have very powerful tools. Our computers are much faster and better. Our algorithms are more efficient. And there's a lot more data available. And that's what makes things possible today than it did about 70 years ago. But the foundations were established a long time ago. I'm not going to go through the entire timeline here, but in the early days, artificial intelligence had a lot of promise. And of course, the community has always hyped up the performance of AI and its potential. Right? So they believed that we would have machines that could talk and communicate in natural language by the 1960s or 70s, but that never happened, right? And there were periods when people were really disappointed. There was this disillusionment with artificial intelligence, and those were referred to as the AI winters. You see this term called AI winter, so there's a lot of promise, there's a summer of hope, and then the winter of despair. But researchers have continued to make strides, and things began to really change around 2010. By 2010, I think we had very powerful machines, like I mentioned before. Computational power was greater. Algorithms became better. Our data processing capabilities increased. Cloud computing was available. And all of these things made it possible for us to actually do the kinds of things that we are doing today. Right, from 2010 to the present time, we have made, the whole world has changed, as you all know. But the real landmark event, the watershed moment came in 2017 when a very interesting paper was published by Google. And this paper was about a new architecture called Transformer. And this architecture has the one that has led to ChatGPT. So when OpenAI released ChatGPT in November of 2022, the whole world became aware of the possibilities of AI, right? And today, it's hard to find a person who doesn't use GPT, right, in some form or manner. All school kids are using it. Our students are using it to do their homeworks, to learn from it. People are using it in the organization to help them with their coding. It can automatically generate programs for you. It can automatically generate advertisements for you. So the potential is enormous, but we see that the timeline goes back about 60, 70 years, right? And has brought us to the present moment. I must say that the present time is very, very exciting. I really wish I were 50 years younger and knew as much as I do, right? So with this, let me move on to the next slide and give you some definitions. Let's start with some very basic definitions of artificial intelligence, right? In very simple terms, we want to enable our machines to simulate human intelligence, right? So what do I mean by that? So artificial intelligence is really the ability of computers and machines to be able to perform high-level cognitive functions, such as reasoning, planning, problem solving, critical thinking, communicating in natural language. We want our machines to be able to do all this and automatically learn just the way humans do. And that is the definition of artificial intelligence. In other words, in very simple terms, we want to simulate human intelligence. The question then is, what is machine learning? Artificial intelligence is the discipline, and machine learning happens to be a subset of artificial intelligence. And the goal of machine learning is to make our machines learn, right, from experiences, from data, without explicitly programming them to do so, right? In the past, we tried to simulate human intelligence by giving rules to the computers, right? We would give the rules and we give the data, and the computer would then apply the rules to the data to come up with insights. Today, we don't do that. What we do is we give the data, we give a lot of data to the computer. We give the labels, right? Labels are things like, here's a picture of a car, and we label it as a car, and the computer learns from that. So when it's presented with thousands of such images, it learns to recognize a car. It doesn't matter what the shape and size of the car are or what the color of the car is, but it learns from that. So the idea of getting machines to learn without explicitly programming them to do so is called machine learning. And then finally, there's something called deep learning, which happens to be a subset of machine learning. It uses what are called neural networks. Neural networks were fashioned after the human brain, right? The inspiration was drawn from the human brain and neurons and how these neurons interact with one another in order to accomplish everything that humans do, from consciousness to the ability to speak, to the ability to recognize things, and so on and so forth. And so that is what deep learning is. So we use lots and lots of layers of neural networks in order to accomplish, very complex tasks. Right? So these are the definitions. And of course, the definitions get a little technical. When I do a program, we actually go in and look at some examples. But in the interest of time, let me move on and talk about different types of learning that happen within computers. Okay. So fundamentally, there are three types of learning, right? The first is called supervised learning. Imagine how your kid, right? Imagine how a child learns from real world data, right? So I can think about my own son when he was about 1 or 2 years old. I would walk to the store with him and I would point out different objects, right? I would point to apples and say, this is an apple. Point to a banana and say, this is a banana. Point to a car and say, this is a car. And very soon, my son has picked up all these things, right? Next time we see a car, he says car. Sometimes he makes a mistake. Sometimes he points to a bus and says car. and I have to correct him, right? But human beings are pretty good at looking at examples and learning from them. We don't need many examples. We don't need thousands and thousands of examples of cars to be able to recognize a car. When I've seen one, when I've seen two of those, I pretty much can recognize a car, right? And that exactly is what we mean by supervised learning. So in supervised learning, the computer is presented with data and what are called labels. Labels are nothing but the target, what we are trying to predict. So for example, let's say I'm trying to distinguish between apples and bananas, right? Or apples and oranges. I can show the picture of an apple or show thousands of pictures of an apple and label it as an apple. And that would be the data presented to your computer, right? You can also show thousands of pictures of oranges and label those as oranges. And now what the computer does is it uses an algorithm to figure out the patterns. It looks at the size, it looks at the shape, it looks at the texture, it looks at many different parameters and automatically learns these patterns, right? And finally, when I give it a new picture of an orange or an apple, it's able to distinguish between the two, right? And this is fundamentally how learning happens within a computer. And this type of learning is referred to as supervised learning. So everything that you see today, if I'm trying to predict fraud in a banking application, if there's a credit card fraud, let's say you're using your credit card in a foreign country, right? And suddenly you get a text message from your bank saying, hey, your card is being used in a different country, right? Are you using it? Are you traveling? How did they detect this? They detected this by using a supervised learning algorithm. The algorithm detected a pattern. It discovered that it is an unusual transaction. And so it flagged this to the company. And the company sent you a text message to confirm that you were the authorized user, right? And once you send a confirmation back, it then lets you go ahead with your transaction. This is the idea of supervised learning, right? So everything that we do with predictive analytics, when I take text and predict spam versus no spam, that is an example of supervised learning. When I try to predict if a particular scan, let's say you have a CT scan for cancer, and I look at the scan and say whether it's cancer or not cancer, that is an example of supervised learning. So supervised learning basically means you take data, you take labels, and try to predict those labels when you're presented with new data, right? It's also widely used in image and speech recognition technologies, right? So with this, let me move on to the next type of learning. Okay, so in the first case, in supervised learning, we need labels. Labels are very important. But sometimes you don't have labels, right? We only have data. For example, we have a lot of customer data, right? If you're, let's say, a telecommunications company, you have data about your customers, the plans, how they use the cell phone, how many text messages they send per day. You have a lot of information, right? You also have information about their payments, whether they pay using card, whether they make their payments on time. How do you make sense of all this data? When you have thousands and millions of customers, how do you make sense of all these customers? One way to make sense is by doing what's called clustering or segmentation. Marketing folks have been doing this for a very, very long time. They take all the customer data and try to segment them to identify, what each segment represents. So for example, one segment may represent very responsible customers. Another segment may represent customers who are willing to take risks. Another segment may recognize customers who are delinquent in their payments, who are always late in their payments. So depending on the segmentation, you can offer different types of programs. You can offer different types of products. You can also give different levels of service to them, right? And this idea of clustering and segmentation is referred to as unsupervised learning. So unsupervised learning basically is the idea of recognizing patterns from large amounts of data. It is used widely, for example, in something called market basket analysis. When you go to the grocery and buy things, right? So people buy bananas, people buy cereals, people buy beer, people buy peanuts, right? So what is the probability that somebody who buys diapers will also buy beer? This is an old example that's often been cited. What two products will people buy together? All of these patterns can be discerned using something called market basket analysis. So if I find in somebody's basket orange juice, what's the probability that they've also bought bread along with the orange juice? And if they bought bread, what is the probability that they bought eggs with it, right? So this idea of figuring out what customers buy together is very useful in marketing because that helps with merchandising, it helps with pricing, it helps with the way you place your item in a shelf, and so on and so forth. Okay, so this is what unsupervised learning is. Next slide, Federico. Finally, we have this thing called reinforcement learning, which is very fascinating. This is pretty much how a lot of human beings learn. We learn from trial and error. We try to do something, we make a mistake. Hopefully, we learn from the mistake and do not repeat it, right? So computers that learn from making mistakes and by doing so, in this particular example, in reinforcement learning, we reinforce good behaviors and we penalize bad behaviors. So there are for every action in the environment, a particular actor would accumulate rewards and penalties, right? Penalties would incur certain, certain. If you have a penalty, it's a bad thing, and therefore, if it's a video game, for example, you may lose some points or you may lose some gold coins because you made the wrong choice. Rewards, on the other hand, are there to give you some benefits. In a video game example, you could gain more gold coins, for example, or you could go to a different level based on some good actions that you take. So take the example of a self-driving car, right? How do they train these self-driving cars? It is run by artificial intelligence, but it has to be trained to run on the streets, right? And every street is different. Every country is different. Every state is different. For example, a car that has to run in Alaska would have a completely different terrain. There would be snow in the background. There would be a lot of ice. The roads would be very different. The rules would be very different. A car in India would be very different, right? The streets there would be probably very crowded. You'd find cycles. You'd find dogs and cats on the streets. So how does an autonomous car navigate the streets of Alaska and Bangalore in India without any effort? The way they train these cars is by using reinforcement learning, right? And reinforcement learning teaches a car how to not make mistakes. When it makes a mistake, it gives it a penalty. When it makes a good decision, like if it stops at a red light, it gives it rewards. And it learns to maximize the rewards and minimize the penalties. That's the idea of reinforcement learning. It's widely used in game playing, in teaching how robots can play soccer, how to play the game of Go, how to play chess, and so on and so forth, right? It has a lot of such applications, and that's what reinforcement learning is. To summarize then, we have three types of learning: supervised, unsupervised, and reinforcement learning. All right, so next slide, Federico. I'm terribly sorry about my voice. It seems to be breaking down. I'm just recovering from a cold and a cough. I apologize, but I'll try to do my best. Okay. So what then are the opportunities that we have with the AI? We know that AI is transforming our world. It's revolutionizing industries. It is enriching customer experiences. It's streamlining business processes and business operations. It is creating new business models. It is creating new types of products and services. We know all this, and a lot of companies are benefiting from this. We know about the Googles of the world. We know about Netflix. We know about Uber and all these other great companies, Meta, right? New products and services are coming in. But let's look at some industries, manufacturing. In addition to robots that actually do your assembly and that do perform certain tasks on the shop floor, we see that a lot of automation is happening using artificial intelligence. All you have to do is to look at, the manufacturing plants of companies like Amazon to see the enormous strides and the level of automation that AI is permitting, right? What this does is it increases the speed, it increases productivity, it improves the quality, right? And therefore, overall, we tend to benefit. The economic benefits are enormous, right? People are talking about 15 to 40% of economic value being derived from AI. In fact, there are some reports that say that about 50% of all that human beings do in organizations will be automated by about 2040 or 2050, right? These are enormous things, enormous claims, right? Logistics. If you're trying to, predict your inventory, for example, or you're doing demand forecasting, you're trying to predict bottlenecks in your supply chain, right? All of these things are now being automated through AI, right? Of course, you have to be very careful with the word automation. Automation does not always mean that you're going to completely replace a human being, right? I think of this as augmentation rather than as automation, right? It is to augment human capabilities. It's to enable the humans to do even better. It's to free up humans so that they can focus on more complex tasks, on more creative tasks. You see, most of the AI systems today are very good at pattern matching, right? But what they are not very good at yet is reasoning about the real world. Human beings are extremely good at reasoning, hierarchical reasoning, spatial reasoning, navigating the real world. Human beings excel at these things, at problem solving. Now, when you combine pattern matching with reasoning, you can have the benefits of both these worlds, right? Our computers and AI systems are getting more and more intelligent. But at the present time, I think human beings excel at reasoning. And together, I think we can accomplish a lot more than either one alone, right? Customer service is another area that is being enriched by AI systems. You know about customer service, you know about customer call centers that are completely being manned by AI systems under the supervision of human beings, right? And these offer very consistent service. The quality of service is very good. They may not be as empathetic as human beings, but they are getting there. They're learning to recognize when human beings become angry, for example. They learn to control their tone. They learn to change the tone of their voice based on human reactions, right? And these machines are getting very, very good at recognizing human signals and interacting with them. So we will see that customer service extends not just to businesses, but you'll probably see that AI and other systems will be used, for example, in hospitals, for example, to take care of patients, in hospice care, where the dying, the sick and the dying, have to be taken care of, and these machines may play a huge role in comforting these patients. We'll probably see a lot of these machines being used in elderly care, right, in rehab centers. So I see the potential for AI in all these different centers where human beings, there's a huge shortage of human beings, and computers can really do a fantastic job when monitored closely by human beings. Next slide, Federico. Of course, healthcare and medicine are probably the areas that are going to change the most, in my opinion, right? AI is already being used in diagnostics. You know, several academic studies that have shown the benefits of AI in diagnoses, right? Breast cancer, for example, or lung cancer, or predicting Alzheimer's even before it occurs, to be able to predict when a child would develop end organ failure, you know, after surgery, right, or other kinds of dysfunctions. The ability to predict sepsis, for example, well before it occurs. All of these can help us save lives, right? Help the doctors intervene before the event occurs, right? So I believe that in the not so distant future, we will be able to predict things like heart attacks well before they actually occur, right? So AI diagnostics is going to play a huge role, I think, right? And as more data becomes available and as more people start working on these systems, and with better algorithms and better optimization, we will see that the level of care will go up, and hopefully the cost of medication will come down as well. And I really believe that this is probably the only way to reach countries where there is no healthcare at the moment. You know, there are many countries. We think about privileged countries. We think about rich nations that have all the AI and all the benefits. But think about all the poor nations that don't even have drinking water, that don't have education, where medical facilities are almost zero, right? And these countries, I think, can really benefit from artificial intelligence applications, you know, when they're deployed from a remote area, right, with very little effort. I believe the world will be a better place, right? Of course, there's good and bad. We can talk about the bad side of things, but I'm an optimist. I'm looking at the utopian side of things, and I believe that there is a lot of good things that will come out of all this. Personalized medicine, we talk about medicine and why it has to be personalized. Every patient is different. All of us are different. We have different metabolisms. We have different genetic structures. And today we know that personalized medicine works. AI can help us with targeted medicine, right? And a lot of work is being going on in this area. Okay. Perhaps the biggest innovation is going to happen with the discovery of drugs, right? Discovery of vaccines and new medicines. We know that recently, I don't know if you've been following the news, but Google's DeepMind, they have a system called AlphaFold. They were able to discover something like 200 million proteins within a very short period of time, right, using artificial intelligence. In fact, the CEO of Google DeepMind, Demos Hannibus, was given a Nobel Prize in medicine for this, right? And this is fascinating if you think about how artificial intelligence can enable researchers to combine molecules, right, and to discover new molecular structures and new drugs and new treatments. It can also allow us to identify patients for clinical trials. So the potential is enormous. I've listed only three things here, but you can imagine all these other things within healthcare and medicine that will be completely transformed by artificial intelligence, right? Next slide, please. Okay. Of course, in our everyday lives, I think we will see a lot of changes. I expect to see a lot of personal intelligent agents, virtual assistants, right? And these could be, in fact, if you think about other things along with AI, you talk about Google Glasses, Meta Glasses, we talk about augmented reality, we talk about virtual reality. Now combine that with that power of AI, and our whole world will be a completely different experience. It'll be an immersive experience. When you go walk into a museum, the museum will come to life. I could actually sit here and look at the Panama Canal, and actually the whole canal comes to life. I can see the bridge opening up. I can see the ships going through the canal, all without leaving the place, leaving my location, right? And I see how these assistants are going to change the way I learn, change the way I behave, change my experiences, right? The whole world is going to be very different. Same thing with home devices, right? If you look at smart homes today, you already have a lot of climate control, you have blinds that are automated, you have music systems that automatically will change depending on your taste. The air conditioning is set to the temperatures that you like. There's so much automation that's going on, even with our smart homes, right? And just like smart homes, there'll be smart hospitals, there'll be smart everything. You can think of smart devices of all kinds, right? And you'll see more of personalized recommendations from what you read to the music that you listen to the movies that you watch. You can see Netflix, if you've been watching Netflix and you see how personalized their services are just based on your viewing habits. That's the fascination. That's the wonder of what's going on with everyday activities and AI, right? Next slide, Federico. And of course, we cannot forget autonomous vehicles. I don't think we're there yet. My test of how an autonomous vehicle really works is to put a car in a place like India, where I grew up. It's impossible, I think, for people to drive. And you can imagine what an autonomous car would do when it's placed in a country like India, where everything is unpredictable, right? So I don't think we are there yet, but we have made tremendous strides. I think they're pretty good for parking, for example. And people, at least my friends who own Teslas, they tell me that the autonomous part of the vehicle really works well, right? And I think it's a matter of time, right, before the roads change, before the technology changes, and soon I think we will have self-driving cars and things. But a lot of things around that will change. Compliance has to change, liability has to change, insurance has to change. We have to think more about, who's liable when an accident happens, right? Is it the insurance company? Is it the driver? Lots of issues to be sorted out. But we'll talk about that when we discuss the challenges. All right. The next thing that I've listed here is called robotics process automation, right? Now, everybody knows robotics. You've seen pictures of robots walking around in the assembly plant, assembly cars, painting cars, and so on and so forth. I'm not talking about that. Robotics process automation has to do with software robots. They call software robotics or software bots, 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 right? These bots are capable of performing, automating repetitive, routine tasks that are typically rule-based. Imagine human beings processing contracts every day. You probably have a few people looking at contracts. You're looking at, expiry dates of contracts. You're looking at clauses of contracts. You want to know if a particular contract matures on a particular day. So people looking at this day in and day out. These tasks can be very easily automated, right? And that's what robotics process automation is all about. In fact, there's an area called intelligent document processing, right? Companies have 80% of their data in unstructured format. Unstructured format is text and video and audio and things like that. Intelligent document processing automatically can take all this text and process it, right, and give us wonderful insights. It can create a dashboard. It can show us, what's going on. It can give us historical data. It can give drill down capabilities, and that's what intelligent document processing is all about, right? And I always tell companies, if you don't know where to apply AI, start with intelligent document processing. It's a low-hanging fruit. It's very productive. It increases productivity. It reduces time. It frees up people to do more creative things, right? And this is fairly easy to automate. Smart mobile applications. I think a lot of applications, AI applications, will appear on mobile platforms, right? Your smartphones and other devices. And I think we will soon see AI-powered applications, for a lot of the things that we do, right from learning systems to transacting businesses with banks and so on and so forth. All right. Next slide, Federico. And a whole bunch of other applications, right? So in education, I see how it's transforming education in the way students learn, the way they consume information, the way they produce information. Of course, there is a lot of cheating that will go on because ChatGPT knows the answers to many things. It knows the answers to my homework problems. Students can use ChatGPT and very easily find shortcuts, but that should not prevent us from using them. I believe there is more good than bad with GPT and other things, right? The learning is going to be fantastic. And combine that with immersive technologies like augmented reality, learning then becomes a very fun activity. It becomes exciting. You're going to be able to bring the whole world to life. Imagine studying about cars. Let's say you're a car mechanic, you're studying to become a car mechanic and you want to understand how a car works, right? In the past, you take apart a car and you would work through an engine and things like that. Now imagine doing this in virtual reality, right? The whole world comes to life in front of you. You're able to take the car apart in virtual reality, put it back together. You can learn from your mistakes and so on, right? They're using it in smart hospitals now. They're using it in nursing schools. UTA has a very good nursing program, right? We are among the top 10 nursing programs in the country. And our nurses are being trained on smart dummies, right? These are not human corpses, but they are smart dummies on which you can actually perform operations. You can go and look at the heart and you can perform surgeries. You can do all these things on smart dummies and learn from that. So education is going to change in a very big way. And of course, there are challenges, but I think there will be a lot good coming out of this, right? Banking, everybody knows how important banking is, right from fraud detection to managing all the loans and loan prediction. Banks are going to change in the way they operate, right? And I think you'll see huge. You probably already see huge changes with AI in banking. Okay, but I think with time, you will see that it's not just AI, but I think you'll see a variety of technologies coming together. If you put Internet of Things, you put blockchain, mobile applications, and AI, and you combine augmented reality, you combine all these different technologies, and you'll have wonderful new things, new models, and new services and products that you cannot even imagine, that we cannot even imagine today. Human resources, everything from recruiting to hiring, recruiting to predicting when an employee will leave, to predict employee satisfaction. So whole range of applications in HR, right? A lot of companies have started using tools to automatically filter out candidates. You can receive thousands and thousands of resumes. Can I use AI to automate the process of selecting candidates? Now, you have to be very careful about this. Of course, humans should always be involved to ensure that the final decision is with the human and not with the machine, because you don't want to have lawsuits later on when a good candidate is rejected, right, by these systems. But I see that AI is already beginning to increase productivity in human resources by reducing the paperwork, by making it easier for them to process information, by creating predictive algorithms to predict human behaviors, to predict the behaviors of their employees, right, and so on and so forth. Okay. Marketing, I've listed marketing the last, but it's probably the first area to embrace data analytics and AI. Everything from media generation, content generation, to advertisements, to predicting customer churn, right? Is a customer likely to stay or leave? Customer lifetime value. I think the potential is endless, right? And so marketing, understanding market insights, understanding customer demands, and to be able to deliver even before the customer knows that he or she wants a particular product, that is what's going to happen with marketing, right? Now, I could go on and on. I think there are many fields that I've not listed, like insurance. Insurance is undergoing huge changes, especially the way they process claims, right? Claim frauds and claims is a huge thing. And now I know a lot of insurance companies that have started automating this. They have automated fraud detection. Just the text information that's sent, people try to detect frauds and try to go from there. Okay. Next slide. I am left with very little time now for my challenges. So let's get to the challenges, and I'll very briefly mention all the challenges. Next slide, Federico. Okay, so the first thing that comes to mind is job displacement. Okay, but like I said, I'm an optimist. And if I look at all technologies that have happened in the past, right from the Industrial Revolution to everything from the computers, the personal computers, every stage, people said, oh, this is going to take away jobs. This is going to, displace people. Of course, displacement will happen. Okay, I'm not. Let's face it. The reality is that displacement will happen. Our roles will change. With AI, even the white-collar jobs will change. Right? All of this is going to happen. Right? But I believe that a lot of roles will change or be omitted altogether, completely gone. But new roles will emerge. New jobs will emerge. They're saying that you know over 97,000 different new jobs will be created, right? And this is only going to increase. If you think about AI generated content and AI generated applications, think about the internet. Okay, let's look at the internet as an example. When internet came in, it revolutionized businesses. People moved online. Became easier for us to reach customers. It became very easy for us to create websites. It became easier for companies to go virtual without actual office buildings, right? But did they reduce the number of people? Certainly not. People had to adapt, people had to change, they had to reskill, they had to upskill. So you will see all that happening. Okay, so I see a lot of new jobs, I see a lot of reskilling, a lot of upskilling going on within organizations. And good organizations don't want to let good people go. They want to retrain their people so that people and machines together can be far more productive, can create far more jobs, create far more revenue than either one alone, right? Next slide. Along with this, we have huge concerns about biases. The data that you create, you train your machines on can be problematic. They could be biased. They could have biases against women, for example. They could be biased against people who are marginalized, people from countries, people of different ethnicities or different genders. So all of these biases do exist in data. So it's up to us to ensure that these biases are detected, mitigated, or completely eliminated, right? That's very important. So fairness, transparency, explainability, all of these things become important. It's not enough for an AI system to make a decision. It should be able to explain why it made that decision. It should be able to tell us the exact reasoning, just the way human beings do. If a doctor tells you that you have a particular problem, you have the right to ask the doctor, why? Can you tell me more about it? Tell me why you think I have this problem, and the doctor should be able to give you a reasoning. Same thing with our AI systems. Only then would we have trust in our AI. Building trust is very, very important. Start trustworthiness and transparency and accountability, right? Who's responsible when an AI system goes wrong? Who should pay for the damages? Who is held responsible? Is it a person? Is it a company? What are the regulations around this? Next slide, Federico. Right? So we also have concerns about the data security, about the protection of our privacy, and regulatory compliance, right? And compliance is just evolving now, and there's compliance everywhere. We have GDPR for storage of data. We have laws from EU. We have UNESCO. We have WHO with its own laws. We have the US AI Bill of Rights. We have so many different regulations that are coming in. How can a company become compliant, right? Next slide, Federico. Yeah, so I'll stop with this particular slide. This is organizational readiness, right? So how mature is your organization, right? This is a slide from MIT. They have done a lot of work with many companies, and they come up with 4 stages of enterprise AI maturity, right? You can go through this when you have time, but fundamentally, organizations, you can see that 28% of the organizations are at level 1, where they're still beginning to explore these new technologies. It's ad hoc. Maybe there are a few people there who understand AI. They're still exploring. They're still trying to educate themselves on AI, right? And then the next stage is where some of them have begun to see the potential. They're looking at the business impact of AI. They're coming up with some pilot projects. It's very important to create pilot projects that are not, even if you fail, it's not going to be very expensive for you. The key thing is to understand that with AI, a lot of things you will fail, all right? And the failure is inevitable. So you should be willing to experiment and learn and move on. So that's why it's important not to do your pilots on very expensive projects, right? So about 34% of the companies are at this stage trying to figure out business value and trying to align AI pilot projects and to show that it actually works, looking at proof of concept, right? And then you go to the third stage. Companies are now far more mature. They've seen initial success. Now they're trying to replicate the success across the organization. Data architecture becomes important. Governance becomes important. Regulations become important. Accountability becomes important. And more importantly, you have to create and foster an AI mindset, right? And this has to be through the organization. The culture has to change because many organizations, culturally, they are unwilling to change, right? So top management support is extremely important. I really believe that AI training should start with top management, with CEOs and top level executives. Short workshops, 1, 2 hour, 3 hour workshops to show them that, wow, this technology is really, really cool, that it can be trusted, and that you need a certain way to look at organizations. And so it has to be very systematic. And finally, You have companies that have AI in their DNA. These are Netflix and Meta and Google and Microsoft and all of these companies. They think, they breathe, everything they do is AI. And from customer service to operations to new products and services, everything is driven by AI. Everybody is thinking about data. They realize the value of data and how you can draw insights from that. All right. So the last slide just summarizes everything that I've talked about. I'm sorry for a couple of reasons. One is my throat was giving way. The second thing is I'm sorry I have to rush through many things. I know these are all wonderful topics. I wish we could do a 1 day workshop on this whole thing, with hands-on. That would be really fantastic. And but this is my presentation. I'll take some questions. I'm sorry I've gone over a little bit, but I'll be happy to stay on. My time is yours. I can stay on for as long as you want and take any questions you might have.
Thank you so much, Nerur. Thank you so much. We have a good question. How do you think a feasible method for ethics and AI can be obtained? How to stop LMs, hallucination, and provide actual truth?
I didn't get the first part. I understood the last part about hallucinations and reliability of outputs and things like that, right? Yeah.
Yeah.
What's the first part?
How do you think a feasible method for ethics and AI can be obtained?
Okay, so here are a couple of things. First, let me address the hallucination and reliability issue, right? Now, when I talk about AI, remember what I said at the very beginning of my presentation. AI goes from supervised, unsupervised learning, deep learning, and then you have GPT, right? I did not talk specifically about GPT. The problem of hallucination and other things is more a problem with large language models, right? And yes, I fully acknowledge that there are hallucinations. I fully acknowledge that reproducibility of results is a problem, right? These are well acknowledged in the literature. One way, like I said, is always involve humans in the loop. Human should always be in the loop, right? And to verify, to look at the sources, and so on and so forth. The hallucination problem will remain. It's getting better. If you followed the evolution of GPT, you'll see that it's getting better and better. But again, it has to be used with some caution. Humans have to be in the loop. Humans have to verify the sources. Humans are ultimately the final decision makers, right? So it gives you insights, but always go back and verify your sources. Okay, that's the first way. Second thing is about ethics and governance. I think ethics and governance start as at several levels. First, the data scientists, the people who actually build your AI applications, should be trained on ethics. They have to understand what it means to be ethical. They have to understand how to detect biases, how to remove biases, what is fairness, right? What is accountability? Ultimately, they have to understand how to prevent biases from coming into the applications. And then you have to test applications on different things. Many of the systems that have been put out in the marketplace, right, and were withdrawn because they were found to be unfair. For example, Amazon's facial recognition system. Yeah, that system could not recognize colored people. An African American researcher at MIT, the system did not recognize her face. When she put on a white mask, it recognized it, but it could not recognize her color, right? Because the application was not trained on a diverse population, right? Now, if you look at a lot of the data, it is coming from the Western world and Eastern countries, Asian countries, all of those. The idea of wedding, for example, if you take wedding, the idea of a wedding in India is very different from the idea of a wedding in the United States. So if I show a picture of a wedding in India and ask GPT, what is this? It might come up with some ridiculous answer because it's not being trained on that data. All right. So you have to train people on ethics. More importantly, the organization has to have data governance and AI governance. It's very important to have a governance structure, right from a board of directors that looks at AI governance, to AI. Some companies are following AI councils or AI ethicists. They even have a chief AI ethicist, right? And this person's job is to ensure that all applications meet AI standards, that you have meet regulations. And today, many companies are going for third-party audits. You bring a third-party unpartial, right, somebody unbiased to come in and verify that your systems meet the requirements, meet the regulations, right? So these are some things that organizations are doing in order to mitigate the concerns with ethics and some of the other challenges I talked about.
Thank you so much. We have Jose raising hand. Federico, you can open the meet, please.
I had a question, Professor Nerur,
Sure.
and the question was, can you give us some real examples of some of the projects on artificial intelligence that your students in the Master of Science in Business Analytics has done to solve a problem or to come up with something new?
Okay, very good question, Oscar. And sorry, I neglected to mention that. So, as part of our master's program, every student will work with a company, right? So, we have been interacting with several companies, many startups recently, to engage in different projects, right? I'll start with some of the early ones that we did. There's a company that I forget the name of the company right now. It's escaping my mind, but it's a company that was in the healthcare industry. You know, they were providing solutions to doctors, to insurance providers in the healthcare industry, right? And this company used to gather a lot of healthcare data, right, about acquisitions, for example, which hospital acquired which hospital for how much money, right? And these were all obtained from text information, from Google alerts, right? And so the first project that my students worked on was to automatically gather text data from Google alerts. They would go to the internet, scrape data from Google News, collect all this information, and then use artificial intelligence to extract information and then put that into a database, right? So this literally, actually, this entire process completely eliminated two full-time employees' roles, right? Those two employees now could go and do other things. But by automating this using AI and populating this database, they were able to save two jobs, right? Two complete jobs, and do it faster, better, and it was more accurate. Subsequently, the next group of students took what the first students had done and then built a dashboard around that. And this dashboard actually would give them insights into all the current details about the healthcare industry, right? You could ask a specific question like, tell me what is happening in heart disease, right? Which hospitals are involved? How much money are they spending on this? Which other hospitals did they acquire, and so forth, right? So that is an example of what we did with the healthcare industry. Let me give you a second example. This was for a marketing company. I think it's based out of New York. And this company does what is called neuromarketing, right? And what neuromarketing is they are trying to draw insights from videos. So, for example, if I'm presenting something on a video, can somebody analyze my video to understand my personality, to understand who I am, right? Just from the way I speak, from my mannerisms, from the expressions I use, can I detect my personality? There are different personalities. People could be extroverted, they could be introverted, they could they could be open, they could be agreeable. So you have different personality traits. So the goal for the students was to take these videos, analyze the videos, and come up with personality characteristics of the persons presenting those videos, right? And then the marketing guys would take the personalities and try to use that for selling products to them. Okay, that's yet another example of a project that our students worked on.
Sounds
Fantastic.
great.
Thank you.
Sounds great. We have the quick question. Jose, go ahead very quickly. for the
Thank
time.
you very much, Dr. Nerur. Thank you for a wonderful presentation. It was absolutely fantastic. My question is, how can we keep up with the rate of change that's happening in AI? I'm in a 6-month course, and every 3 weeks the syllabus and the course content is to keep up to date with that, so we don't become technologically obsolete. Thank you.
Okay, so for this, let me explain what we are doing with Ericsson, the telecom company, right? They started this with us about 6-7 years ago. It's a 4-course certification that we are doing with the company. So what we do is we actually go to Ericsson's campus. Friday, my class starts at 3 to 6. I teach at Ericsson. Then Saturday from 9 to 12, right? And these students bring their actual projects to my classroom. They learn whatever I teach in the class, right? Is applied to an ongoing project. And more importantly, I try to update my syllabus very frequently. In fact, during the course, I update my syllabus to bring in new techniques and new things. So this way, the students get exposed to the latest developments. You're absolutely right. Every day, this field is changing, right? But by engaging with the telecom engineers on real world projects on a day-to-day basis, we are imparting these skills almost in real time as things happen, as things unfold. Okay. Now, you have to understand that you're always going to lag behind. You're not always going to catch up 100%. But once you have the foundations, and you will automatically learn to learn. You have to be adaptive, right? And I think the key is for an organization to build a culture of learning. So, for example, after we started this program at Ericsson, the students have self-organized. We've taught about 6 or 7 cohorts so far. That's about average of 70 students, right? 70 telecom engineers have actually created a brown bag session. Every Friday, they have a brown bag session. 1 hour or lunch, they bring in speakers, right? From different companies, different professors come and talk to them about the latest developments. This is how they keep up with what's going on, right? And we try to take our latest research and present it to them as well. So for an organization to keep up with all this, you bring in speakers, you give students access to things like Coursera so that they can take the latest courses. You bring in researchers in your, universities in your neighborhood to come and talk to you guys. Do some projects with them, do some joint projects with professors. I think these are the only ways to keep up abreast of what's going on, right? And I think short-term courses, 2-hour class, right? 2-hour update every month to top-level executives on what's going on, I think can be very beneficial, right?
Thank you so much. Thank you for the question, the audience. Dr. Incredible conversation. I hope to see you soon in Panama, Oscar?
Yes, well, I want to thank you, Giovanni, for letting us to present in the Innovation Committee this presentation of Dr. Nerur. And we thank you, Dr. Nerur, for your presentation. It was very informative, and in 1 hour, you were able to give us lots of information and pass my rewards and my appreciation also to the Dean and the Associate Dean of the UTA College of Business. And see you soon.
I certainly will, Oscar. Thank you so much for this presentation. I thoroughly enjoyed it. I again apologize for my voice, but there's so much to cover in this, and like the last person asked, there's so much to learn. The field changes every day, and I hope this is just the beginning of our journey. I'm really looking forward to being there. In fact, my sister was in Panama last week, and she had wonderful things to say about the place, and especially the Indian food. She said that she was surprised to eat at an Indian restaurant and told me that the food was even better than the food you get that we cook at home. So I am really looking forward to the opportunity. And thank you so much. I thoroughly enjoyed it.